Let's begin Chapter 4. Section 4.2 is really just some terminology. You'll see in there the additivity property and I forget the other one, the scaling property. So read through that section, but there's really not a whole lot in that. So we're going to skip to section 4.3. 4.3 is on superposition. Superposition allows us to solve complicated circuits in an easy way. And what you're going to find out when we do this section is it looks like we're actually making the problem harder. And we are, because some of these problems we could do faster with mesh or nodal, but we're doing them with superposition just to show the method. So it's about learning the method right now, not about making the circuit easier to solve, but later it will be a technique that you'll use to make the circuit easier. All right, so here's the steps in superposition. Our first step is to deactivate all but one source. What does that mean? How do we, we need to say all but one independent source. Or deactivate all, independent sources but one. Because we don't want to deactivate dependent sources. We never do that. What does it mean to deactivate a source? So let's look at a voltage source. I have this voltage source. I want to deactivate it. So I want the voltage to become 0. Remember the definition of voltage, the potential difference between 2 points. So if 2 points are the same, there's no potential difference between them, therefore the voltage is 0. So to deactivate a voltage source, we just replace it with a short circuit. Now, our voltage is 0. We've deactivated the voltage source. Current. If we want to deactivate a current source, we want no current to flow through, what do we need? We need a big hole. So current can't jump over a hole. It doesn't have legs. So if we make a big hole with an open circuit, well, now we have 0 current. Current can't jump through there. So we've deactivated our current source. So it's important to be able to think through that process like we just did, instead of memorizing. So don't memorize that a voltage source needs to be a short. Think about it. What does it mean to have 0 voltage? It means there's no potential difference between the 2 points. It means they are the same point. Okay? Our step 2 is repeat. So we repeat this procedure. I guess we need a 1.5. 1.5 is going to be solve. So we deactivate the sources. We solve for whatever it is we're looking for in the circuit. Then we repeat that. We deactivate all the sources but a different one. And we solve. And in the end, we add up the answers. So this is one of those that's really better done by an example. So let's just look at one here. I have, it says problem 4.8 and then it's crossed out. So it just may be a made-up problem. We have 4 ohms. I don't know why it's giving us the 4 volts across there. That's really not necessary. So let's go ahead and get rid of that so we don't have extra floating information. And I'm writing it again, even though I said I was going to get rid of it. A little crazy moment. 6 ohms. And what we're looking for is current I. Okay, so if you're given this problem on a test, you're likely not going to go, oh, superposition would be the easiest way, because it's not. I would do mesh. We already know the mesh value in here, right, because we have a case 1. You could do nodal just as easy because you only have one node. You know the voltage there. So there's easier techniques, but we want to look at how to do superposition. So we're going to deactivate all independent sources but one. So let's say we're going to keep our 20 volts active. And so I need to deactivate all the other ones. Well, that's only one. So everything else remains the same. I deactivate all my other sources. So I create an open here. They have a big hole. These wires are essentially not doing anything. They're just hanging out there. So I don't really even need them. Doesn't matter. V equals IR, right? We know that. This is the negative side, so I have minus IR. My voltage is 20 across these two. My resistance, right from here to here, is 6 plus 4. Or my I is minus 2 amps. Another way to do that, if that was a little bit confusing, just think of this as a mesh. So I want to write around this loop. I have 20 plus 6I plus, there's nothing on the other side now, 4I equals 0. That's going to give me an I of minus 2 amps. Same thing, okay? So you can look at these different ways, do whatever makes the most sense to you. Now I want to look at step 2, which is repeat. So I want to look at having my 5 amps active, meaning I want to deactivate my 20 volts. So if I want to deactivate this and I want there to be 0 voltage, I need a short. Now there's no potential difference between these two places. I have 6, 4, that's the I we're looking for, and I have 5 amps. So how do we want to solve it? Again, we have options. We have different ways. We could do nodal, we could do mesh, we could do whatever. But I want you to notice that this is all now, since this is a short, this is all one node. That means the 6 and the 4 are in parallel. They're sharing this node, and they're sharing this node. When they're in parallel, and we have a source, it's easiest to use current division. Again, not the only way to do this, but a convenient way. So for current division, we're looking for the current through the 4 ohms. So that means that my other one, the 6, goes on top, add the resistors on the bottom, multiply by the source, and I get 3 amps. So that finishes our step 2. Now we need to do step 3, which is add. So we're going to take the I we got from here, which was negative 2, the I we got from here, which was 3, add them together, and we get our answer. And make sure that's correct. Good. I got 1 amp on here too. So again, important things to remember is how to deactivate the sources. The other important thing is do not deactivate do not deactivate dependent sources, the diamonds. Never deactivate a diamond. It just stays there and you solve the problem with it there, and that's all you got to do. Okay? So you only deactivate independent sources.